So recently, my family and I went to Canada, and when we crossed the border, there was a speed sign that looked like this, and it was interesting because it actually wasn't miles per hour; it was kilometers per hour, right? We take everything for granted because here in the United States of America, we see a sign like this and we know it is miles per hour. So the question is, are these two equal? And if you've never noticed, you look at your car speedometer, and you'll notice that there's two sets of numbers going around that circle. Um, then you move on to somewhere like Australia or Europe or United Kingdom, and you see something like this. Notice how difficult this is. All we see are numbers, but we don't know what units they have. Units are a very important thing, right? If I go ahead and tell you that I need 20, you should be asking 20 what? Push-ups, dollars, candy bars, health units, etc. Okay, so uh, we run into a problem of units. Historically, you have cases of, for example, the story of Noah and the ark. He was told to build an ark, and it was so many cubits. The length of a cubit is a distance from your elbow to the end of your middle finger. The problem is all of us have different cubits, right? Can you imagine a T-Rex and its cubit versus an orangutan and its cubit? Okay, so another historical one is the foot. So the British unit of the foot is or feet is based on the king's foot. So at the time, if the king's foot was 10 inches long, then that's what a foot was. If your king had tiny feet, then the foot was a smaller unit. So it came to a point where people realized, you know what, this unit, everybody has their own units, everybody's weird about things. Let's go ahead and standardize them. So the French came along.
Système international d'unité.
We're going to call this the SI system or the metric system. They came along and said, okay, we're going to go ahead and standardize this. It doesn't matter how big your foot is, it doesn't matter how long your arms are, this is always going to be the same. So we have the meter, lowercase m, represents length. It also represents displacement, which is maybe a term that displacement you haven't used before, and we'll bring that up quite a bit in this class. The kilogram is a symbol of it's a kg, lowercase kg, and it represents mass, not weight, mass. The difference between mass and weight is that your mass is the same no matter where you go. So obviously, if you go to space, how much do you weigh? 0. Because in order to weigh, you have to have gravity acting on you. And if there's no gravity, then then you have no weight. However, you do exist, and therefore you have a mass. Okay. We have the second, lowercase s. It's a measurement of time. The ampere, capital A, is electric current. It's the same, the abbreviation of an ampere is an amp. So sometimes it's also listed as an amp. Yes, it is the same amp when you play electric guitar or you're talking about car systems, sound systems. The Kelvin K is a measurement of temperature. And we sometimes use Celsius as well, capital C, degrees Celsius. The candela, CD, is a luminous intensity. And finally, the mole, you're going to never guess this abbreviation, M-O-L. Ah, snap. That's the amount of substance. You will heavily refer to the mole in chemistry. So let me ask you this. What does mph mean? I would prefer that you write miles per hour as follows. Miles per hour. It means how many miles do you go in 1 hour?
Alright, we're traveling from Logan to Boise, and I just proposed a math question to my beautiful wife, Chelsea. And the question, very difficult to calculate, is if you are traveling 80 miles per hour, how long does it take you to go 80 miles? Okay, what do you think, Chel? Let's go through the process. What do you think?
Well, if I run the mile in about 9 minutes.
Wait, what about the tire turning thing you were talking about? You think that affects it?
Well, I'm just guesstimating probably about, it turns about 400 times in a mile.
That's just like guessing calculations?
Yeah, I don't know how you would work that out.
It'd be tough.
Yeah, so, I don't know, because if I run a mile in like 9 minutes, then, I mean, but that's when I'm out of shape. When I'm really in shape at like 7 minutes is when I'm like really in shape. And that takes me a mile. And we're going 80 miles. I'm running at about probably 10 miles per hour, if that.
Yeah.
And that's pretty fast for a human being, I think. But, I mean, it's got to take at least like 58 minutes or something.
58 minutes? It's pretty close.
To go 80 miles.
Do you want to know what the answer is?
What?
Think about 80 miles per hour.
Yeah.
So how long does it take me to go 80 miles if I'm traveling 80 miles
driving
per
fast.
hour?
You are driving faster than a minute a mile.
Yeah, totally.
So I would whack 80 in half, and that's 40. Because, I mean, you're probably going 2 minutes a mile.
Just whack it in half.
Well, depends on it. I mean, some cars' tires turn faster than others.
Yeah, definitely affects it.
Because, I mean, I think a truck probably is slower because it weighs more.
Mm-hmm.
But I think it also matters if your car's a stick or automatic.
Okay, Chal.
What?
Think about the term miles per hour.
MPH.
MPH. So if I say I'm driving 80 miles per hour, that means I'm going to go 80 miles in an hour.
No, you are not, because you are driving faster than a mile a minute. I can run 1 mile in 7 minutes, and that's a 10. Okay? So, I mean, that's booking it too.
Okay, so if I'm going 60 miles per hour?
Then it'll take about 30 minutes. I would just cut it right in half.
I'm trying to explain the answer, but...
Well, you are not making sense, because I make sense, you do not make sense. My car's tires may be they're kind of a little flat, so they may not move as fast as like a police officer's tires that are full, but
Okay, Chel, the answer?
My tires are turning maybe, I'd say about 400 times per mile.
Okay, I'm going to tell you the answer. You ready for the
No, they
answer?
gotta be like 1,000.
You ready for the answer? The answer to...
You don't know the answer.
I do know the answer.
You can guesstimate just like I guesstimate.
I'm not guesstimating. I'm using math and science. I'm using my own term. Okay, Chel. The answer to the question, how long does it take me to travel 80 miles if I'm driving 80 miles per hour? The answer is 1 hour. Your guess was close.
So say you drive 60 miles per hour at 60 miles. You want to go 60 miles at 60 miles per hour. Is that an hour?
Yep.
What about 40 miles at 40 miles per hour?
Then you will go 40 miles in 1 hour.
You cut that in half. You're going more than a mile a minute. Okay, let's time. Right now, let's time and see. Please stop filming.
Spoiler alert, if you're traveling 80 miles per hour, how many miles would you travel in 1 hour? So if we're traveling, in problem 3, if we're traveling at a rate of 80 miles per hour and the time is 3 hours, How much did we travel? Well, using this formula, we have distance is rate times time. Don't write this like 80 mph because that makes no sense. Write this as 80 miles, per 1 hour. And the time is 3 hours. Maybe put it over 1. Now you'll see what happens. See, when you do this, you recognize what's really happening. And I know you know the answer is 240, but I need you to show how the units cancel out. Hour cancels out, hour cancels out. 80 times 3 is 240. And I have miles left, which is the correct unit in this problem for the distance. So whenever you do any problem in physics, I would expect you to always write out your units, and if it's a fraction, write out the fraction, and then see if the units cancel out. They should cancel out, giving you the correct unit that results in the answer. Very important in physics, okay? So in the above problem, though, what complications would arise if the time were given in minutes? So imagine instead that it's 80 miles per hour in 3 minutes. Miles per 1 hour, and it were 3 minutes. Can I cancel these two out? So you see the problem. I need to be able to convert this. Now, of course, you know how many minutes are an hour, right? We have 60 minutes in 1 hour. Notice how I wrote this. I wrote this in such a way that these minutes would cancel each other out. And then these hours would cancel each other out. So then if I wanted to get the answer, I would do 80 times 3 and then divide it by 60. And then the correct units for this would be in miles. Okay, so if we end up getting different units and we have to convert them appropriately and use different fractions for that. Let's try it again, but this time, what if it gave it to us in days? Okay, so let's say it was 80 miles per 1 hour, and I needed to know what happened in 3 days. Feel free to pause right now. See if you can figure it out without me. Pause. Okay, we're back. So we have 1 day is 24 hours. So what happened then is these days would cancel out, and then these hours would cancel out. And then if I do 80 times 3 times 24, I would get the appropriate amount of miles. Okay?